All right, now that we've discussed sum and difference formulas, I just want to do a couple of practice problems where we will verify, evaluate, and solve some trigonometric equations using some of these sum and difference formulas. So let's start with a basic one here. Let's take a look at this one, and this should look pretty familiar to you. This is just a variation of a cofunction identity. And what we want to do is we want to verify that this is indeed the case. So we notice that we're taking the sine of some angle minus another angle. So we can kind of think of this as the sine of some angle A minus some other angle B. So if we think about this in terms of the sum and difference formulas, we know that sine A minus B is equal to sine A cosine B minus sine B cosine A. We can just apply that formula here to rewrite this as sine of theta cosine of pi over 2 is our second angle, minus the sine of pi over 2 times the cosine of theta here. And this here is all supposed to be equal to negative cosine of theta. This is what we're trying to verify. Now let's go through here and simplify. We know the cosine of pi over 2, that's equal to 0. So we can say the sine of theta times the angle, or times 0 is equal to, all that's going to be equal to 0. Sine of pi over 2 is equal to 1. So we've got minus 1 times cosine of theta. And I could bring that out here. Anything times 0 is just 0. So we've got negative cosine of theta is equal to negative cosine of theta. So it's a pretty straightforward verification there. All right, now let's try a problem where we're going to actually evaluate some expressions here. Now, take a look at this here. We've got the tangent composed of arc cosine of root 2 over 2 minus the arc sine of 0. Now, the arc cosine of root 2 over 2, that's an angle. And so it's important for us to know that this is some angle theta. And arc sine of 0 is also going to be some angle. So just make sure we understand that it's an angle that's coming out of these inverse trig functions. Now, fortunately for us, this is actually pretty simple. This angle here is actually should be an angle that we know. Pause and think about this for a second. This should be angle pi over 4 in radians. And the arc sine of 0 should be 0. So this is tangent. This can be rewritten as the tangent of pi over 4 minus 0. Now, I know you're looking at this right now and you're probably thinking, wait, I actually can evaluate this without using any identities. And you'd be correct. This is equivalent to just tangent of pi over 4. And we know the answer to this is going to be 1. Now, suppose we did want to use an identity here. We wouldn't need to, but it might be good for practice for us because in a moment we're going to do a similar problem where we actually will certainly need to use the sum and difference formula. But I could just want to make sure that we practice writing this as tangent of pi over 4 minus the tangent of 0 all over 1 plus tangent of pi over 4 times the tangent of 0. This is just good practice working with some of these identities. Well, tangent of pi over 4 we know is equal to 1. Tangent of 0 is equal to 0. 1 plus, again, tangent of pi over 4 is 1 times 0. All of that just simplifies to 1. And this is confirmed here. All right, now let's try a problem similar to that, but this time we're pretty certain we are going to need to use our identities here. Again, arc sine of negative 12 over 13 is some angle. That is true, as is the case with arc cosine of negative 8 over 17. So the problem is these aren't ratios that come out of angles that we're accustomed to working with in our unit circle. So all we can really do is just call this some angle A. Same deal for arc cosine of negative 8 over 17. That's not going to be any pi over 3, pi over 6, or pi over 4 angle. So we'll call this angle B temporarily. Now, I don't know what angle A is, but I can still sketch its right triangle that represents the side lengths for angle A. We know that when we're taking the arc sine of a negative input, that means our angle is going to produce a negative sine value. And given what we know about the range restrictions of arc sine, that means angle A must be, let me actually draw this, we're using both. That means angle A must be in quadrant 4. So that is to say this should be angle A. It's a negative angle here in quadrant 4. Now, we don't know what angle A is exactly, but we do know that taking the sine of angle A gives me negative 12 over 13. So we can apply the Pythagorean theorem to find our adjacent side or our x value here, but this actually turns out to be a Pythagorean triple. Can you figure out what that adjacent side is? You're right, it's 5. Now let's do the same thing for angle B here. Knowing what we know about the arc cosines range, we know that negative 8 over 17, this is going to give me an angle here in quadrant 2. Angle B is going to be in quadrant 2 somewhere. This is angle B, where my adjacent side is negative 8, my hypotenuse is 17, and this also is a Pythagorean triple. This opposite side is going to be 15. So I don't know what my angles A and B values are, but it doesn't really matter. I can still evaluate my trig functions here. So now here's where we use our sum formula. We know that this is cosine of some angle A plus B. Well, we can rewrite this then as cosine of A times the cosine of B minus, don't forget that it's the opposite sign here, minus sine A sine B. So if I rewrite this here, cosine of angle A is going to be 5 over 13. Cosine of angle B is going to be negative 8 over 17 using our triangles here. Sine of angle A is negative 12 over 13, and sine of angle B is 15 over 17. From here, let's just clean this up. This is negative 40 over 13 times 17. That should be 221. And we're subtracting a negative angle, so this is going to be plus 12 times 15 is 180 over 221. And our final answer here should be 140 over 221. Okay? All right. Go ahead and try this next problem on your own, and you can check your solutions with what I have up in our school website. But now let's actually try a few practice problems where we're actually going to have to solve some trig equations. This is the third type of problem that we're accustomed to working with. All right, so here, let's actually jump to the more challenging problem. Let's actually try that. I think that first one was something that most students can handle, but let's try this problem like this. So we're going to use our sum and difference formulas to solve this equation here. Well, this right side can be rewritten using the difference formula for tangent as tangent of pi minus the tangent of x all over 1 plus tangent of pi times the tangent of x. And over here, this would be 2, and applying the sum formula for cosine, we can write this as cosine x, cosine 3 pi over 2, minus sine of x, sine of 3 pi over 2. And all of this is equal to 0, okay? So let's go through and evaluate so that we can simplify. We know that the tangent of pi is equal to 0, so we have just negative tangent of x in the numerator. And in the denominator, again, if tangent of pi, if all of this is equal to 0, then our denominator is just 1. So we can just write this as negative tangent x. Over here, we've got negative 2 times cosine of 3 pi over 2. All of this is equal to 0. So that means this entire term is 0. Sine of 3 pi over 2 is negative 1. So we have negative sine x times negative 1. So negative times negative, that's a positive sine x. So all of this is just sine x is equal to 0. Okay? So we've got here, and there's a couple ways that we could do this, but I'm going to rewrite tangent as negative sine of x over cosine of x plus 2 sine x. And now that we have a sine x in the numerator, we can actually factor out that sine x and write this as negative 1 over cosine x plus 2 is equal to 0. So let's set each of these equal to 0. Sine x is equal to 0. That means x is equal to 0 and pi. And over here, negative 1 over cosine x plus 2, if that's equal to 0, we can set this equal to negative 2. And that means cosine of x is equal to positive 1/2. If we just multiply both sides by the denominator there. So from here, my angles are going to be x is equal to pi over 3 and 5 pi over 3. So we're going to box this and box those. Okay, and you always want to check your original equation for any domain restrictions, but I've got sine and cosine, so I'm good to go there. All right.